Our rendering looks pretty poor right now because we haven't really delved into the shading properties of our fluid. First thing up, let's just adjust the renderer. We're using Maya software as our renderer. And I can open up the render settings either from the status line or from the render view window. Open render settings window, I'll just go to Maya software, and in the anti-aliasing quality, I'll set the quality to production. And I can do another rendering. This time I'll do an IPR rendering, or interactive production rendering. It'll speed things up. Click the IPR button in the render view. It draws once, renders the frame once, and it says select a region to begin tuning down here at the bottom of the window. So I'll drag a rectangle around my fluid. And now any changes I make to the shader will be reflected immediately. So I've got my fluid selected in the viewport, and I'll hit Control A to open up the attribute editor. And before we even start playing with the shader attributes, we want to just turn off some of the basic render stats. So I want to scroll down. I'm looking for render stats. Here it is. Open that up and just make sure cast and receive shadows are off. This is going to be lit from within. And then also in the lighting section, we just want to make sure that real lights is off, because this, once again, is going to be lit from its own incandescence and not from reflected light in the scene. Okay, now we can start to clean up these rough edges. In the fluid shape node, there's also a shading quality section, and I can turn that up to a value of 2. It's starting to soften that up a little bit, maybe as much as 3. I'm on a pretty fast computer, so it's coming out fairly well on here. And once I add a texture in here, it should look pretty good. I don't usually need to take it up past 3. One more thing in here is the render interpolator. If we set that to smooth, it'll be even a little bit softer yet. And by the way, the IPR rendering does not exactly correspond to the final production rendering. So when in doubt, we can do a full render. I'll save this IPR rendering by clicking the Keep Image button, and then do a full render. So I can compare the difference. That's an IPR, and that's the full rendering. So just a little bit of extra smoothing and anti-aliasing in the full render. Good, so now we can start playing around with some of the color attributes. I'll go back to IPR so we can see those in real time. And I want to go to the shading section and start playing around with incandescence. So incandescence is currently set to temperature. And that's good because we do have temperature coming in. We go back up here, you'll see temperature is set to dynamic grid. So if we change these incandescence values, we'll get different results. Or if we change the input bias, we'll shift it up and down. So I'm actually going to set this one, this black one, instead of being black, I'll set it to blue. And then move that around. Move the red one around. And this yellow one, I'm going to set to a very bright white. And I like to use the HSV, hue saturation value mode. And I can turn that up. In fact, it's already turned up past 1. So you're not limited to a value of 1. So I can push it up into super bright, value of maybe 1.5. That's a very rough approximation of our pillar of fire. Let's make it a little bit better. First of all, I'll go back up to the top of the fluid shape node and increase the base resolution to maybe 40. Rewind and play that back, and hopefully I'll get real-time playback, and I still do. And that's going to help a lot. Render. And now I've got enough detail in there to start modifying that and playing with that. Scroll down, and I'm looking into contents details. We've already set the density attributes, but we've yet to play with turbulence. Here's turbulence. The strength of turbulence should be pretty low. Don't take it up past maybe 0.1 or 0.2. I'll be conservative and give it a 0.1. You will have to rewind and play back in order to see the result. And now my plume of flame is kind of drifting around more. Even with a value of 0.1, it seems pretty strong. Watch out for situations like this where it looks like your pillar of flame is hitting the edge of the container. That's a very common situation. You can help that by reducing the strength of the turbulence or increasing the frequency. So frequency is the size of the turbulence effect. I could increase it to something very high like 1,000. And the speed is the rate of change for the turbulence, so I'm going to increase that quite a bit as well to 100. I'll have to rewind and play back again. And now there's a strong turbulent effect, but it's constrained in a smaller area because the frequency is so much higher. We're going to add a texture to that and make that more beautiful too. So I can try maybe a greater strength, and I'll have to rewind and play the simulation each time. We've also got temperature, and under temperature, I'm going to increase the temperature scale and give that more prominence. And you'll see that that immediately changed the color as well, because remember our incandescence is being driven by temperature. We've also got the buoyancy of the temperature. Remember that we set the density buoyancy to a negative value so that it would flow in the opposite direction. So I'll do the same here. I'll give this a negative buoyancy of maybe 5. And that's going to cause the temperature to flow through the container. Starting to shape up. We can give it a little bit more dissipation. And we can actually add more overall density and temperature to the simulation through the fluid emitter node. So I'll go over there for a moment. And you'll see in the fluid attributes section, we have the amount of density per voxel per second and the amount of heat per voxel per second. And I can set those both up to higher values. Hit enter and rewind. And that's going to push out more density and more heat. Looking better.